People are like, it's not amplified, you know? So, yeah, that's just right. Okay, are we on? Good. Hello, everybody. Hey, how you doing? Welcome to everybody to EdinburghJS. Thank you for turning out this evening, and hello to the people watching on the live stream. Conrad, who wasn't able to find dog sitter, I hope you're tuning in. So we've got a couple of great talks lined up for you tonight, but first a couple of quick kind of housekeeping things. Firstly, there are no fire alarms scheduled for this evening, so if you hear a fire alarm, that means there may or may not be a fire, and you should exit the building the way you came in and go out the front, essentially. There are toilets around the back, so if you head down the corridor, they're down at the end of the corridor. If anybody needs that, please help yourself to whatever remains of the pizza and beer. There are a few survey things hanging about. We'd love it if you could fill out a little survey just to sort of let us know who you are and let us know if you want to speak at EdinburghJS in the future. So please do fill out those. Morag is here from Code Clan, so if anyone has any questions about Code Clan, please do talk to her. Tonight, the catering was sponsored by KPV. So thank you very much to KPV. A little round of applause for them, thank you. And Alec is here to do the first talk from KPV Lab, and we'll be talking about WebGL. So please do take it away. Thanks.
Thank you. I have to say I had absolutely no input in the paying for purchasing of pizza or beer, but you're very welcome. Hi. Okay. So I'm going to talk about WebGL. One of the problems with technical talks is it's hard to know where to pitch the level, because we've got a big room of people with tons of people ranging from people who have just pivoted careers, working at, studying at Code Clan. I know I've met a couple of you tonight who are current Code Clanners. And we've got people like my boss and perhaps other people in the room who've been working with WebGL far longer than I have. So the question is, where do you pitch a talk? And what I've decided to do is pitch it right at the beginning, I hope. If I get that wrong, I apologize. And so think of this as hopefully a 101, bit of an entry level. I'm going to try to achieve three things in the next about half an hour. I'm going to talk about what WebGL is, what it's for, why it's here. Then I'm going to give you a practical example. If you're interested in this stuff, how do you get started? So, you know, what are the first lines of code that you can write? How can we get you from nothing to WebGL experience in, let's say, 10 lines? Then I'm going to talk to you, try to teach those of you who don't already know, two fundamental concepts of WebGL. But we'll get to those later when perhaps you're more ready for them. All right. What is WebGL? What is it for? The web is a system that obviously we've all grown up with it, we've all lived with it for years, but it's a system of conventions that allow us to communicate information to one another. HTTP, HTML are standards that we use to convey information back and forth. One computer sends that information out, another computer receives it and knows how to parse it and display it on a web page. Since that became a thing, people have been pushing at those the constraints that HTML creates. So CSS has continued to evolve and has become more and more powerful. HTML has continued to evolve and become more and more powerful. We have Flexbox, we have 3D transforms, we have all sorts of things that we didn't have in the early days when a blink banner going across the screen was considered high tech. Early days, I'm going to go with mid-90s. A community ever since then has been pushing to try to expand web information, the stuff that we can communicate to each other safely through browsers rather than downloading software and downloading data and then consuming it more natively on the machine, pushing what web browsers can achieve. And WebGL is not the latest, but perhaps the latest but one example of this, and the most widely used technology that exists now for allowing us to push graphics through the internet to browsers and have web have 3D graphics display natively on display on the web. I always get this thing where I start off talking and I don't forget to breathe. And then after about 2 or 3 minutes, I remember that I'm supposed to breathe. And then I'm fine. Excuse me. I don't know why it happens every single time, despite the fact I've been doing this for a while. Okay. So, since 1995-ish, web technology has been going forward. Let's just talk about a few of those briefly. Flash came out in about 96. Was that a hiss? Did I hear a hiss from the crowd? Apple killed Flash in 2009. I know I was there. I was a Flash developer at the time. Flash is actually a really important part of this story because most of the people who now work on 3JS, which we'll get to in just a minute, came from Flash. They were Flash developers. 3JS was built on technology that was built for Flash. Flash was an amazing technology. Before that, all you could do is have static web pages with static text, blocks of text. Very hard to make it look pretty. Flash, I built an animation for a hip-hop nightclub, which spray-painted El Segundo across the screen. It was a hip-hop nightclub just off the Royal Mile when I was a student. And I did that in 1997, and no one had ever seen anything like it. They thought it was the coolest thing in the world. Yeah, indie games, mini games, yeah, absolutely. SVG has kind of become a kind of natural successor to Flash. SVG and Flash share that they're vector graphics, but they're fundamentally 2D vector graphics. And 2D vector graphics is cool, but it doesn't get you all the way to what you want to do. And increasingly what people wanted to do was build 3D worlds, 3D games, the way that they were seeing on PlayStations and Xboxes and natively on Windows. Canvas was a kind of midway step. It gave you direct access to pixels. So you could say, here's a canvas, and it's a block of HTML, it's a rectangle in HTML, and I can change each pixel. I have full control. I can do whatever I like. And that technology still exists, and we still use it. We've used it in our work. It's not going away. I think it's a keeper. A big difference between Canvas and WebGL, and this is something that we should talk about and become aware of during this talk. All software engineering is a set of trade-offs. You can write a function that does a very narrow thing, and it's super simple. Simple to understand, simple to use. If you expand that function, make it do more stuff, it becomes more complex, more complicated to use. That's true of functions, and it's true of whole systems. So a high-level system, I'll call, something that's relatively simple to use but relatively constrained. And let's think of HTML as one of those. There's not a lot you can do with it. What it does very well, but it's kind of limited in its flexibility. WebGL, on the other hand, is a low-level system because you can do pretty much anything. There are constraints, and those are important ones. And WebGPU, as a teaser, is trying to fix some of those, but we're not really going to talk about that too much. Sorry, Patrick. It's a low-level implementation, so there are very few constraints. It means you can do an awful lot. You can do more of what your imagination can think of. It doesn't get all the way to PlayStation and Xbox. That would be too much, and there's reasons for that too, and perhaps we can talk about them. If I forget to mention them later, you can ask if you're interested. So WebGL and WebGPU in brackets, they're low level. They give you much more access to the GPU. And once you've got access to the GPU, you can do things that you can't do at the high level. JavaScript is a single-threaded language, so it allows you to execute one thing at a time. And if you want to iterate over a bunch of things, you have to do them in sequence. The GPU, if you think of the CPU as this kind of big, massive machine, the GPU isn't that at all. It's a tiny, small machine, but thousands of them. And they can all do stuff in parallel. And that means that if you can make a program that works on a GPU, it can go blazingly fast, much faster than a CPU can, because of this difference in technology.
That's if you have a GPU.
Sorry?
That's if you have a GPU.
If you have a GPU, yes, that's true. I defy you to find a computer that doesn't these days. But anyway, let's move on. If we can have that argument after. Sure. So it's a low-level API. It's powerful, but it's hard to use. Okay. So I told you that we were going to try and go for entry level, and then I told you that WebGL is super hard. So those of you who are code clowns in the room, I imagine now are thinking, well, why the heck are you talking to me about this? When am I ever going to use this? And if you had to start from scratch and build a program without any libraries to help you, just on WebGL, you're going to have a bad time. I don't know if I could without looking up a lot of manuals. I don't know many people could. I'd have a go, but I wouldn't be confident that it was going to show anything interesting. However, don't have to do that. Just as on top of HTML we have React, you can think of as a corollary, on top of WebGL we have Three.js. Three.js is a library built by people who were working in Flash before Apple killed it. On top of those two now, there's a new thing called React 3 Fiber. As we go up through this stack, we go to a higher level of organization. It means that we've added more constraints. We can do less stuff, but it's much easier to do them. And the step from WebGL to Three.js is enormous. It's almost unimaginable. The things it will do for you that you don't have to do for yourselves is amazing. Similar to HTML to React, though I think React is less of a leap. React 3 Fiber spans the two. It takes Three.js and moves it into React for you. So React 3 Fiber lets you write 3D scenes declaratively. It lets you write as if you are writing React, but you end up with a 3D scene. I gave a talk 3 years ago at a Meetup in Edinburgh, in which I was very skeptical about React 3 Fiber, and I still have quite a few of those skepticisms. I think there's a danger that it's a bit bloated, that it's not going to be very performant. If done well, it's exceptional, and it can be as fast as anything you can imagine. Done poorly, it has this risk that if you try and do too much and make it too complicated, it can start to slow down because you make mistakes, and it's easier to get away with mistakes. It's harder to notice you're making them in React 3 Fiber. But with that caveat, it's an impressive piece of technology. So let's have a look at it. I've just added this slide after doing this as a preparation talk and being suggested that I do, and I totally forgot I had it. In order to be able to think in Three.js, think in 3D, we need to have three concepts. First, we have geometry, which is a set of points. I'm going to call them vertices for the rest of this talk, and I hope that's okay. And they create the structure of a model. Right? They create the outside hull of that model. Then you have material. And the material is how it looks, what it feels like. I'm going to start interchanging that with pixels. Right? So you have vertices and you have pixels. When you put them together, you get a mesh. And the mesh is an object that always has these vertices and these pixels, and they're mushed together, and they create this shape. So let's look at a piece of code. I've curtailed it a little bit, but I actually wanted to show you code. This is my version of live code for my colleagues who are. I'm willing to do live code later if people want me to, but I suspect you'll all be fed up of listening to me by then. So I should talk about this. Right, we've imported Canvas from React 3 Fiber. And we've declared canvas there, and we've added 2 lights. If you don't have lights, you can't see anything. This is true of everything. It's true in this world too. And we've added a mesh, and I've put a variable in for rotating it. And imagine that that variable is being mutated up in this ... So it's just kind of updating, and the rotation is happening. And I've said dodecahedron geometry, one of the Platonic solids. Gotta love Plato. And mesh physical material, that's a name of a material that exists in Three.js. And you just kind of have to know them. But they're pretty simple to use. For whatever reason, I've said opacity here, but I don't actually use the opacity. We'll see opacity in a second. And the color, I'm mutating the color. So I'm changing the color on a loop around a kind of rainbow. And the thing you see behind is not actually generated by this code, but it more or less is. Like this code plus like 3 or 4 lines generates that spinning dodecahedron that you see behind it. So that's pretty cool. Not a lot of code, pretty easy to get going. Every bit of the model can be controlled. So here, I started rotating the mesh. That's the mesh, the object at the object level. Then I changed the opacity. That's changing the material. Then I start messing around with the vertices. That's the vertex level. That's the geometry level. So I'm moving all of those 3 things separately, and they're making together quite a complex animation. Really not a lot of work involved in doing this. The geometry is the hardest bit, but it's, again, not unachievable. The effect is quite good, I think, for 3 variables being changed, or 3 aspects of a model being changed. So very good, but I'm working with Platonic solids. How useful is this going to be for me? You know, if you want to build an indie game, or you want to experiment with something a bit more interesting, well, you can pull models from artists into your scene and use them rather than generating your own geometries. So I'm going to do the same thing. Let's see what it looks like when you pull an artist's model in. And here I'm importing Blackfish. What could it possibly be? And I'm adding the canvas again, and I'm adding more lights, because if you don't have lights, you can't see anything. And I'm doing something that should look pretty familiar, but this time I'm changing position. I wonder what that will do. Oh, okay. So I've got a black fish. That's handy. And I'm changing its position. And okay, I'm cheating a little bit, because the component called Blackfish is just kind of presented to you as a single thing, but you can't just go into Three.js and find Blackfish. But you nearly can, actually, because if you go onto a 3D modeling library and download a free library or pay someone for a library, you can take it to this website and drag the file in and drop it in, and it will generate the code that you need. So the Blackfish code inside that thing, which I can show you, is just the code generated by this website, plus 3 lines that trigger the animation. But really, I'm not doing anything clever, and the results are really quite impressive, I think. Maybe I should wait for you to tell me. There was a problem, and any kind of using of assets creates a pipeline problem. So when I got the fishes from Dennis, who I've not met, but I hope that he will watch this, and thank you, Dennis, for your patience. I was getting animations like this, and it was very infuriating, because I really wanted a fish for my talk, or many fishes, as it turns out. And it turns out the way that he had created the animations, he created a swim animation, then a bite, then a turn left, then a turn right. And for whatever reason, when I could play on the swim, first it did the swim, then it waited till all the other animations would have finished. Then it went back to the start and did the swim again, which was very annoying. And it turns out that artists, sometimes they sequence them up like that, and the importer didn't use it. So I'm not saying that this is pain-free. I'm just saying that the pain is actually quite manageable and small, and it's the pain that you get with any kind of importing an asset in another context. You find, it's not quite how I wanted it, now I have to work out why. But it wasn't that much work. Okay, so I'm going to say those 10 lines pretty much get you from nothing to a 3D model existing in a web page. This is a web page. The entire presentation is written in React 3 Fiber. So there's no tricks here. I haven't baked anything. I'm not pretending. This is we will publish this website at some point when I've tidied up some of the code that I wrote in a rush. I have to remember when to press the button at a couple of points coming up, so just saying that out loud. All right. So I hope I've convinced you that it's actually quite achievable to get going, and that the barrier to entry is actually relatively low because of these libraries. But if you're going to get into WebGL, and I hope some of you will, you should know a few things about how it actually works under the hood. So let's talk about vertices and pixels, but let's go lower, all right? And let's talk about how they actually work. So imagine you've got the simplest possible model, which is 3 vertices forming a triangle. All models are made out of triangles. Well, those triangles enclose a bunch of pixels, and those pixels get colors. Now, you can specify on each vertex a particular color, let's say. And when you specify that color, that doesn't tell that vertex what color it should be. It tells the pixels near it what color it should be. And then the pixels in the middle have a problem, because which one are they nearest to? Well, it turns out that WebGL, the GPU, natively interpolates between them. So you don't have to say anything, you don't have to do anything. You just have to tell the GPU, this is red, this is green, this is blue, and it's here. And then all of those pixels get colored for you on the pixel layer. I think my next slide is going to talk about vertex shaders and fragment shaders, or at least going to say those names. But vertex shader, just think of vertices. Fragment shader, just think of pixels. I meant to change it and I didn't, and I'm annoyed. We can use that underlying technology to produce lighting effects. And this is where WebGL suddenly starts to make a lot of sense, for me at least. So what I'm going to do is I'm going to take that triangle, I'm going to shine a light right at it. Okay? So let's start with that triangle again. But I'm going to turn all the vertices purple. And then I'm going to shine a white light right at it. Now it's flat right now because I've specified the normals, these little arrows I'm sticking out, to go straight up towards the light. So the model now looks completely white, even though its underlying color is purple. But if I move those normals, if I make them move out as if this was a curved surface between those vertices, then suddenly the white light hits the middle, but on the outside, the light kind of hits and bounces off a little bit. It doesn't look quite so white, and the underlying purpleness comes through. I'm not changing the position of the vertices. What I'm doing is changing some of the information that's passed to those vertices that is then passed to the pixel layer, and the pixel layer uses that information to work out how light should bounce off it. How that looks in effect, in reality, is like this. So here's a cylinder, okay? It's 16 vertices at the top of the cylinder, and it's 16 vertices at the bottom of the cylinder. And they make triangles all along the cylinder. Right now, when you can only see one line at the top, at the ends of them, that's because the normals are all pointing as they would if it was a perfectly smooth cylinder. And the light then is bouncing off this cylinder as if it was perfectly smooth. When I move the normals out, and you can see them leave like that, that's the normals as they should actually look if they were sticking out of the triangles that they're in. So the triangles, this is not a perfectly smooth cylinder. This is a 16-sided polygon at the top and a 16-sided polygon at the bottom. So you should see 16 sides around the outside, right? And sometimes you do. But just by moving those normals towards each other, we trick the eye into an illusion of smooth. And with this, we can produce smooth surfaces out of flat triangles, and the person doesn't know any difference. It's a remarkable bit of maths, simple bit of maths actually at the end of the day, but your perception of it makes it really powerful. And actually, you see this every day when you see 3D graphics. This is more or less, well, this is one of the two good ways that this is done. Yeah, I shouldn't say this is the way it's done, because this is the way it's done when you have vertices, and there's another way, but that's way too complicated for right now. So, pixels, vertices and pixels, and normals and lighting are two concepts of 3JS and WebGL that allow you to, that produce these effects, that I hope that you remember from this stuff. That's me, that's my talk. My name's Alec McEachran. My Twitter handle is Alec McKee. I work at KPV Lab Edinburgh. If you like this kind of stuff and think this is really interesting and super cool and you would like to get into it, we are hiring, but I would say go and build something using this technology and send it to us, right? There's nothing more impressive than someone who not just doesn't say that they like this stuff, but actually goes out, learns it, and says, look what I did. And if you want to do that, and you do that, and we like it, come work with us. Anyway, thank you very much.
Yeah, so if your portfolio doesn't have a swimming fish in it, it's straight.
You've got to have fish as well.
I've always wanted to add something 3D to my website, because I think you go on like designers' websites sometimes and you're like, oh, there's like spinning stuff and stuff that kind of moves in certain ways with the page. And actually, what you've shown is that to get started in doing that sort of thing isn't that complicated. It's just a matter of actually having the confidence to pick up the tool and run with it. So.
Yeah, I mean, I have to say, that's scratching the surface, and the caverns beneath are deep and possibly endless. The amount of stuff I've learned in working on this full time for about 5 years.
Yeah.
Every year, every 6 months, I learn techniques that I didn't know existed. And,
yeah.
I mean, and I'm not going to stop. I think.
Amazing.
So,
we've got time for one or two quick questions. Does anybody have a question? Hand shot up there. I'm going to hand you the mic for the live stream, so you need to speak loudly as well, speaking to that. So.
Okay, thank you very much for the amazing talk and the performance. I have two quick questions. The first one is, how long did it take you to create the presentation, given that you're an expert? And then the other question is, how many polygons can it handle? So could I, for example, create a 3D scan? And then my question is, how much do I have to decimate it in order to visualize it with WebGL?
The first one is hard. Thank you. The first one is hard to answer, and the second one is it depends. But I'll try and unpack that a little bit. It's hard to answer how long it took because I worked on it kind of at weekends while watching football. But I started it 2 weeks ago, and honestly the longest problem was the fish animation. Why that fish wasn't just animating on a loop was by miles the hardest problem, and the solution was writing an email. The next hardest problem was probably making sure, sequencing the timeline animation, because it's a timeline of 3 or 4 blocks of slides, and then those slides have nested timeline under them, and making sure that that's a React problem, not a WebGL problem. So I didn't have any problems at all at the WebGL level, really. Yeah. Oh, sorry, the other question, how many can it take? How many polygons can it take? How many vertices can it take? That's a really tough question to answer because really the complexity of WebGL is what you do with the vertices and the pixels. So if you're just writing colors based on color attributes, it's called, that each vertex has a color attribute. If you're just taking that color and painting it onto the pixels, millions and millions and millions of vertices, like many millions, tens of millions, I think. If you're doing super complicated lighting logic, shadows, soft shadows, transparencies, all of this stuff, then you have to start writing more than just the output layer. You also have to write you have to do a render from the position of the light to get a shadow. Then you have to take that information and put it back in. Then you have to, like for opacity, you have to write things out to what's called a Z map, so you work out how far into the screen things are, and the complexity just escalates and escalates and escalates. It's using the same GPUs as your Unreal Engine games are, but of course the WebGL creates limitations, which means you're not going to get to that performance. But yeah, it's a lot. It's a lot. Sure.
Somebody else have a question?
Yes, my question is basically because my sensation when I see the GPL, sorry, I forget the name, graphic GPL, the thing is, it sounds extremely complicated for trying to code 3D. So is any software over there, aside the website you send, that use less no code? I have experience in 3D programming before, not as a programmer, sorry, a designer. So there is any software that can convert all this kind of job that maybe you do in 1 month, you do in maybe 2-3 weeks and facilitate everything?
I mean, my friend over here was talking to me earlier. Well, I'm tempted to say, I don't know, let's try ChatGPT. But I'm not sure he might be upset with me. I don't know. Are there tools that automate things? Yes. Depends on the job. I don't know what they are. Sorry. Maybe I've missed the thrust of your question.
It's no automation. It's any software which is more visual than coding.
Oh, I see. Yeah, I mean, if you're more of a designer than a programmer, then Blender, or if you have Deep Pockets, Cinema 4D, or if you, or any of these software, allow you to create 3D models. That's really the kind of the designer stage, and that's what the fishes are a product of. I mean, they're kind of low poly fishes just as an aesthetic rather than as a constraint. But yeah, if you wanted to design a fish and make it animate, you'd do it all in the designing software. And then the last step would be pulling that up into this, and then you'd need a little bit of code, like I showed, to get that into your scene. But yeah, if you like coding less and like designing more, then the design tools will keep you busy for the rest of your career.
Thank you for the answer, but I'm asking this, I'm not, well, I like both coding and visual, but I just always check which one is more efficient and which one is faster, and that's because it was a question.
Oh, I see. Oh well, I'll have my third crack at it then. And then for me, coding is faster than using Blender, but that's because I know code better than I know Blender. So I think the answer is it depends.
Okay, so we'll do follow-up questions on, you're in the Discord. So we've got a Discord server which is available for chatting to us, the organisers, or speakers if they're on there. You can find the link at scottishtechnology.club, and I'm sure you'll be able to
I'm happy
answer
to
any
share the source of the examples that I showed, and maybe a little project that will just create. At least I don't think I can give away the fishes because they're licensed, but I paid 20 bucks for them.
The website,
yeah. So yeah.
I've got a 3D scan in my head somewhere. We can all add that to our website.
Sure. Yeah.
Cool. Okay, so we're going to take 2 or 3 minute break. We've got quite a quick turnaround time for this because the talks are jam-packed. And then Glenn will be back in 2 or 3 minutes to talk about machine learning and text wrangling, and I'm quite excited about this too. So if you need the bathroom, please do that now. There's a few more beers, and please take your seats in 2 minutes' time. Thank you. Okay. Are we live streaming again? Good. Cool. Cool. Okay. Hope everybody had a lovely 5-minute break. I say 2 minutes. I actually really mean 5 minutes. Glenn has been coming along to EdinburghJS since we started it up a year ago, restarted it when there was, I think, about 8 people in the room. And finally, even after months and months of me persistently asking, has agreed to do a talk. I'm really excited about this. JavaScript and machine learning. Obviously, machine learning, that whole thing, big topic at the moment. And I think it's very useful that we know about these things as JavaScript developers and sort of see the kind of wide range of things that we can do. So, Glenn, really excited. Please take it away.
Good evening, everybody. As just been said, my name's Glenn. As traditional with these EdinburghJS talks, I'm just going to do a tiny little intro about myself so you know a little bit about me, but maybe it'll give some context to this talk as well. So my background originally was in informational architecture and design. During the years, I've got heavily involved in development as well, so I've done a bit of node work, back-end APIs and things like that. But the most of my career has actually been involved in a startup that I co-founded about 20 years ago. Was in recruitment, built job boards, did lots of sort of TA tech or talent acquisition tech. I sold it about 3 years ago and exited about a year ago. So in the last year, after having a little bit of a break, I decided I needed something of a bit of a challenge. And what I chose was to teach myself about machine learning. This didn't come out of the blue. The last few years of working in the company that I was involved in, I was head of product strategy and innovation. We had multiple dev teams, usual sort of front-end, back-end teams, UX teams, design teams, data analysts, and a data science team. The products that I was developing were things like recommendation systems for jobs, career pathing tools, things that looked at your career and looked at the skills you'd got and how you moved that forward. And obviously, although I wasn't involved in the day-to-day of the data science, I was involved at a top level with it. And I was fascinated about how the data science team seemed to work very differently to the development teams. They had a different process, they operated very differently, an ethos around research. So I wanted to learn a little bit more because I want to be more empathetic to the people that do that type of work. And I think it'd be really informative to me from a product perspective and from a sort of more traditional development perspective. So I'm not a data scientist. I'm someone who's into JavaScript and development, who's trying to learn. And today I'm sharing with you my journey of how I'm doing and where I'm at with it, because I'm still on that journey. 2 years ago, when I moved up to Edinburgh, I got involved with some of the meetups that are around data science. And I was listening in to a couple of data scientists, and one of them said this: the worst thing about data science is the senior developers, that's probably me and other people, with a lot of domain knowledge, which I have about the subject of our own recruitment, getting involved. And I think it's because we don't approach it with the same sort of processes or ideology that they do. Lots of data scientists read academic papers all the time. They're very academic in it. They talk to each other through academic papers. That's how they communicate. But really importantly, they look at their subject and they come at it from the same sort of scientific method. They come up with a hypothesis and they use experimentation and tests to work out whether that works or not, and they iterate on that process. So this gives you something that looks like this usually. It can vary quite a lot, but usually this is the core of what machine learning processes are. You get hold of the data that you want. That can be really difficult. You learn how to clean and manipulate it. You find some sort of statistical algorithm to help you build your models. Then you test your data, so we're going back to that scientific method. And finally, you rip round over and over again, improving, doing these stages backwards and forwards. So we're going to look at this and look at it through the lens of JavaScript and see if we can do something similar with a technology that's not really well known for doing that type of thing. But first, I just want to look at what the landscape's like. So these are some of the libraries that are used. My specific interest in machine learning is around language processing, so natural language processing. It comes from my background in informational architecture. The grey line relates to the process we were just talking about. Above it are some of the Python libraries that are available. I could have put about 5 times more than that on that screen. There are a huge amount. Down the bottom are some of the JavaScript libraries that are available. That's about it. But we do get coverage. We get coverage across the whole journey there. So we're going to have a look at some of these. Because I don't like make my life easy, like I try to do machine learning with JavaScript, I also am going to look at the data as well in the same way. Most of the libraries provide you with really neat little packets of data that you can learn against. They're sort of all packaged up. They've been curated, audited. They work really well. I'm not going to use them. I want to use something from the real world and make my life even harder. So I'm going back to where I came from, which is recruitment. And the thing we're going to look at today is how to parse out job titles. Job titles are really small, so it makes it quite easy for me to put them on the screen. We don't have to deal with lots of text, but they're actually quite difficult. They can be written in lots and lots of different ways. What I want to do, and what I want to show you through today, is how to parse out specific parts of them. So I want to go for what's referred to as a canonical job title. So here it would be lead UX researcher, not the other bits of information. They're quite useful, like the fact that it's based in Edinburgh and part-time, but it's not of interest to me today. And things like the seniority, so lead, apprentice, junior, intern, those types of things. That gives me a sense of the hierarchy where that job title's coming from. So if I'm not going to pick up one of these nice clean data sets to learn on, I have to create my own. And the way that you usually do this is through an annotation tool. I'm not sure I'm going to pronounce this correctly, but this Docker, or however it's pronounced, is a really nice one. It can be loaded through Docker. You just literally download the Docker image, stick it up, fire it up on your machine. And what I've given it here is just a long list of job titles from the UX space. I've got a friend, Danny Hope, in Brighton, who runs UX Brighton, and he has a job board. He's given me 1,600 job titles for me to play with. The task's actually pretty simple for this one. It basically goes through each of the job titles I've loaded in. It comes into this screen. You basically select the piece of text and then you tag it. So you can see here I've tagged the word senior, I've tagged the canonical area of it, so senior UX researcher as job title, and there's another tag that I've been using for something else there, which we'll forget about for now. Once you've done that, you go through all 1,600. It takes a little while, but you go through them and mark them all up. This tool then exports them in a JSON-L file, so that means a JSON object for every line. I've taken one of these out just to show you what it looks like. It's really simple, the markup of this. The text is the original text that I inputted, so from that list that I put into it at the beginning. And then the annotations that you just saw on the screen in the UI are turned into numbers. So 0 is the first letter, S of senior, and 6 is the R of senior. So it basically shows you what it is there. And there you have it, the data for us to play with. So the next stage is to clean and manipulate data. It's actually the collection and the manipulation of data is the bit that usually takes the time in these projects. And to do this, we need to talk about notebooks. So some of you here might have already played with things like Jupyter, which is the Python notebook. Notebooks are really important in this domain. I suspect they come from the original sort of like lab-based notebooks that people used to use for noting down their experiments and what the results were and the ability to go back and check and reiterate on them. But here, obviously, we're talking about the digital domain. So we've got documents that are used to contain the material to explore and analyze the data set. They have lots of notes in them. They help us understand the concepts and the flows. They're made up of modules, so like little bits of them. You have code, the output from the code, visualization, so that's charts and other tables, etc. Explanatory text, so what was I trying to achieve, what was the outcome, and then usually at the end some sort of statistical results from them. The beauty about them being digital is they can be shared, so you can work with other people and people can learn from them as well. So luckily for us, we actually have a version of this in the JavaScript node environment, and I'm going to jump out of the slides now and demo you exactly how it works. We're going to look both at how a notebook works and also about some of the tools that you can use in JavaScript for playing around with text. So let's hope the demo gods are going to be kind to me and that everything goes to plan. So not that one. We'll come back to that one. Okay, so this is a plugin for Visual Studio. It's called Node Notebook. I don't know why it's called Node Notebook, but it's really easy to install. And once it's installed, you can create these files with an NNB extension. And they have segments in them. It's a bit difficult to see, but if I can start dragging them around, you can see that they're built up of modules. So this bit here is just a markdown module, and I can click and edit on it, and edit in Markdown. And then if I just click here, it turns it into text. So you can put your notes and stuff in it. The more interesting piece is that you can have code areas. So here you can see this is JavaScript. I can change that. I could make it into TypeScript. I can have PowerShells, etc. And these little code areas execute. So if I click on the execute button here, you'll see the little tick comes up and it's executed the text in it. There's a couple of things from a JavaScript perspective to know about these notebooks. They actually, underneath the hood, are only using require, which means common JS to those people that know. So you can see here, the module that I've included is actually an ES6 module. So it uses import from, usually. If you use this little EMS hook addition, it will help you deal with both module types. So you can use both in here. Also under the hood, it converts everything from constants and lets into vars, for those that know that. So it's not really worth using them, to be honest. So although I have got let in there occasionally, it's all been converted. And you can do async awaits directly off the first line, rather than having to be in a function. A few just things for you to note about its usage. Okay, and barring that, it's pretty simple. You can see this is the notebook. You can read down it and you can play with the bits of code. So we're going to go through this and just have a look at a few different things. I've got a few pieces of code here which are really common for doing text wrangling. The first one is called tokenization. This is the most simple version of tokenization. It's a couple of regular expressions. It takes the text here, senior front-end developer, and converts it into an array of lowercase, and it also does takes the dashes out. So it basically turns front-end dash into the normal version of it. This one's actually the text from directly inside of TensorFlow. So you get much more complicated versions of that. I tend not to use these. I tend actually to move to much more sophisticated tree-based parsing of text. The libraries that I used are from a group of people that call themselves the Unified Collective. They build a whole series of modules. I think it's about 130. They deal with parsing of text, HTML, and Markdown. If you use Markdown in the Node or JavaScript environment, you're probably using one of their modules under the hood. I believe the 130 odd modules that this group control are downloaded more than 1 billion times a month. They're in things like Gatsby. The documentation for Node itself is actually written using some of these things. And you'll see in a minute, they're extremely powerful and a really good way to deal with text. So the first 2 lines here is just a parser. It's going to parse in the English, as it says. And the second one just helps me inspect it. So it basically writes it out in the console for us. So again, we've got a little sentence there. And if I press the execute, you'll see what it does. So basically, it strips that text into a tree structure, quite a sophisticated tree structure. So let's just pull out a few different things here. Can you actually all see that? Is that visible to you? So just for example here, the word node, you can see for front end, which is done with the dash in the middle, it's got a piece of text, the punctuation, and the other piece of text separate. Everything's all then structured like this. There are about 30 modules that allow you to modify this. So you can basically rip through these trees and look for ancestors or children of certain nodes and process these really well. I'm just going to show you one of them at the moment. So again, I'm just importing a few different modules at the top. These are the modules that will help us play with it. The most important bit is actually this bit here. So it's called visit, and it allows you to iterate through the whole tree and pull out specific nodes. So what I'm going to ask it to do is just list me all the punctuation nodes, which it's just done there. If I change that to word nodes, it will allow me to just pull out all of the text and stuff. These modules, the 30 core modules like this, can be used to build things like editors, inline editors, any type of text processing tool. Really quite powerful. Moving on from that, we actually have specific libraries in Node that are for language processing, natural language processing. This is one called Wink. I've just loaded it up. It actually has its own model here. This line here, the second line down, is a model, and it's going to help us process the piece of text. I'm just going to fire it off for you. And here you can actually see in the notebook a demonstration of some sort of output, like a proper visualization. It's a table rather than just a console log. And it's done some more processing. So the first thing it's done is it's stripped down my text into this single bits of tokens, as they're called, individual words. The shape is basically the capitalization. Sometimes it's useful to be able to play with the capitalization. Stop words are like, tell me which are the common words that I probably don't want to care about. So we and are considered very common. This type of use of stop words is used in things like Elasticsearch and stuff like that for doing free text searching. The next one along is sort of slightly more complicated. This is it looking at the use of English and deciding whether a word has been used as a verb or as a noun. It's referred to as part of speech, and that's what it's using the language model to determine. And then the last two are ways of shortening text, because when we want to make comparisons, sometimes we want to make the comparisons on the sort of shortened version of it. So let's take one word there, planning. So it's basically both of the stemming and lemmatization have taken that word planning and produced plan. They do the same for planner, planned, and all the variants of that and bring it down to its core bit. The difference is stemming is done through a rules system and can produce words, some sort of text that's not actually a true word, whereas lemmatization always produces a proper word and is done from a language model itself. I've gone through all of that. This is not a full set of all of the tools that are available, mainly just to show you that there are powerful tools in JavaScript that will allow you to manipulate text, just like there are in Python. And some of them are as equally as good, especially the ones around the abstract trees that we looked at, so the tree node structures and stuff like that. And hopefully as well, you saw a little bit of how the notebooks worked. Okay, so if we just go back to my demo. Sorry, where's my, there we go. Okay, so just before we move on to training and stuff, I've missed out a whole section here. I'd love to put it in about how you deal with the text and turn it into numbers, and how you deal with number structures. Those of you who are involved in this area will probably use things like Panda and stuff like pandas and stuff like that. There are equivalents in the JS world, but it's probably too much and too detailed to cover in a talk like this. But if you want to ask a question about it, we can cover it later. So straight on to doing models. So I was going to start with the simple models and move on my way up to the OpenAI stuff, because ChatGPT is just so prevalent at the moment. But let's deal with the gorilla straight away and go straight into it. So if you go in and look at their APIs, they actually have more than just the chat APIs. There is about 70 models that are available through REST APIs off their website. The majority of them are these large language models, LLMs as they're called, and they're non-deterministic, which is very important for you to understand. That means if you give it a prompt, you're not guaranteed to get the same answer each time. Non-deterministic. So for some of the uses that we're going to look at in a minute, that's quite important. They're a class of model that's referred to as transformers, and the other important bit is that they can take fine-tuning, i.e. we can add additional information to make them work better. So let's have a quick look. So I'm sure you've all done stuff like this, or hopefully you have. You go in, you put something in, and I've just asked for 2 sentences about Ben Nevis. Great, it's really useful for doing stuff like that, but that's not what I want to do today. Today, I want to know whether it can help me with that little problem I have about whether I can extract out bits of information about a job title. So now you move on to much more complex prompts. This is one that I've taken from someone else. I think it could be actually reduced a little bit, and it's strangely rubbing the ego of it. You are a highly intelligent and accurate domain entity extraction system. I'm not sure it needs to be told it's highly accurate and intelligent. But anyway, so basically the first top bit is basically giving it a context in which it should operate, i.e. pretend that you're going to be an extraction system that can take out bits of information from me. The bit that's down here is basically telling it about the format that I want the information to come back. And if you can see, it's got some characters in here that look very much like JSON. And that's because I'm telling it basically to give me JSON back again. And then finally, this is your input, which is a very long job title. And this is what it gives me back, a piece of JSON. It's quite interesting because I haven't told it about what labels or what bits of information to extract. It's made that out itself. Some of it's quite good, some of it's not so. So it's extracted, actually, the core job title for me, Senior UX Researcher. Brilliant, it's done that. But it's labeled it up as person, which I think is probably not quite right. I would have called that a job title. And it's done the same maybe for the next one where it said the label is time, but it's a 6-month contract. I might have called that contract duration or something like that, slightly different terminology. But actually it's not done a bad place. Place is Edinburgh. So, you know, it's not doing too bad a job. So I'm going to jump now back into demo mode and I'm going to show you how we can make that work properly for us. So if I go back to here and we go into a different notebook. So I've created myself a little project called Prompt. All that Prompt does, it's a very small wrapper around the API to OpenAI. It basically does the request for me, REST request, and brings back the information, and it just checks that the stuff that come back is valid JSON. And that's all that it's doing. So the first 2 lines here is I'm just calling my library prompt. I've just required it. I've pulled out a couple of objects for it, the prompter and the model for my prompt. The 3 lines there is just me getting my OpenAI key in a way that you can't see, because I don't want someone using it while I'm on stage. And so we're just going to quickly, hopefully we can do this live. Yep, there we go. We can click the different boxes and they're executing now. So the first one we've got here, I'm just going to clear that and see if we can get it to work for you live on stage. So basically, I'm making an instance of my prompt. I'm giving it a template. That template has that big prompt that you just saw and a couple of injection points to put my job title into it so that I don't have to write that all of the time. That's all that's going on here. So the input is that. And the UX design bit is just saying, operate in the context of UX design. If it was something else, like I was having engineering job titles, I'd give it that, just to give it a little bit of thing. So if we press that now, hopefully it'll go. Sometimes it's slow, sometimes it's fast. Nope, it's been pretty fast, it's come back again. And here you can see it's brought back the JSON for me and it's parsed out things like the job title. This time it's got some of the labels a bit better, like position, contract type, duration and stuff like that. But they're not quite still what I want. So you can actually create a prompt where you tell it what the labels are that you want. So this is what I'm doing here. I've just added one more row to it. And again, you can see now, I won't execute it just for speed, but you can see the one that I previously did. It's now giving me the labels that I want, but I've got less material coming out of it. So there's a bit of a compromise that's gone on as we've executed against this. We can go one step further, and I can do an inline fine-tuning. This is basically where I give it examples. So you can see this quite often with prompts, you give it examples. Here it's quite structured. I basically said the text at the top is what I'm going to give you. The labels in this little array here is what I expect back. Have another go. And this time it's come back and it's given me the right labels, but it's given me a little bit more information. So I've kicked it through a little bit more. Now, obviously, sending all of this information in a prompt is not good, so we can actually fine-tune this model. So most of these language models are pretty big and they understand the languages that they've been taught on, but you can layer on top of them. You can give them material. OpenAI allow you to do this by creating a file, uploading it, and then they will give you a new model, which is basically their base model with your fine tunings on top. The file that you create is actually pretty simple. It looks really complicated here, it's very messy, but it's only constructed of 2 things: the prompt, in which my case is the job title, and the JSON that I expect back again. And you do that multiple times. So what I did was I took that annotation that I had from my tool early on, and I created this file from it. And I've got 500 of these. I fired them over to the OpenAI. There's an endpoint for you to load this up, and it created a model for me to play with from that point onwards. So here, we're doing exactly the same, but this time when I create my prompt, well, first off, you can actually also list out the models that are available to you. So this, what you can see here, is me listing out the name. The ID is basically the model name. It's all really quite obscure naming, but that's the model that was created for me. So when I load up my prompt tool this time, I give it a name, and that's the model name, the custom one that's got my fine-tunings in it. We'll forget that little function there. The prompter I'm going to do is I'm just going to fire this prompter off again now. It's got basically the title in it. I've got a stop symbol. Basically, the stop mark is to tell it to stop generating characters or additional stuff after a certain point. The 3 characters you can see there are the 3 characters common to the end of a JSON object. So that's the reason why I've given it that, and I've given it a max token a bit. And I'll fire it off. Hopefully it will actually work. And you can see it come back. And here we go. It's come back again. The function above was just a little JavaScript function that went through that and checked that the words that it gave me are actually in the original text. It's like a bit of railing just to make sure that it's not generating anything that's not there from the original. And it gives me the start and end positions of the text, so the start and end of the characters and stuff like that. So that's how you can use prompting and the general models now to do something really specific. But that's only part of the story, because if we go back to the bit that we were talking about earlier, I don't want to be that developer guy. So realistically, I've just put this up here, sorry, before I go on to that, just to show you what the prompt for a fine-tuned model looks like. You can get rid of all the rest of the junk. You literally just give it the text, a little symbol, which is the arrow symbol to tell it this is the end of my input text, and then it gives you back the JSON afterwards. So going back to the bit, I don't want to be that guy that the data scientists talk about. So if I'm going to use this type of stuff, I want to do it in a proper way, which means I've got to test my outcomes. It has to be done with an experiment. So I haven't shown you here, but in the background while I was creating this, I actually created an API, a rules-based API. For the job titles, I downloaded 60,000 open source job titles and built basically a comparison tool that went through all of the titles and looked for them, just doing simple comparisons, using those tokenizing stuff that we saw earlier on. It found 63% of them. That's a perfect match at 63%. It actually did quite good matches. So let's say I was looking for UX designer. Sometimes it would find just designer or not UX designer, but I was only selecting perfect matches. So that's pretty good. And its speed of operation was something like 94 milliseconds. I'm sure I could get that faster. The version of the OpenAPI one where I gave it the labels, so I told it these are the labels that you should use, that was 79%, pretty good. But when we fine-tune it, up to 95%, I'm sure I could get those higher. This is just my first attempt at it. But now I've got a baseline. I've tested it, I've got a baseline. So you know I said that the prompt looked a bit over the top. I could now change that prompt and see if I could make it terser, i.e. smaller, and better, and know that I've got it better. I'm not just playing, I'm actually testing and coming back and seeing how things work. Interestingly, when I looked at the seniority one had a very strange outcome. The first version of the OpenAI one, where I used labels, was actually really quite low. It was 43.9%. When I looked into the data, the reason is because I used the label seniority, and I expected it to find things like team leader, which it didn't. It found things like manager, senior, and stuff like that. But some of the things that I wanted in there, and it's because the terminology I was using was not very precise. It knew what seniority was in its sense. But as soon as I trained it and said, no, seniority is about all of these things. It includes things like internships, apprenticeships, all of that type of thing. It came back with a much better result. So testing, really, really important. So into the rest of this. I mean, I really think that this is quite powerful, and it can be used for not just the things that I just showed you. It can be used for lots of different other things, and it can be used in a very structured way where you can test it properly. But I also want to learn about some of the more fundamental stuff. So I've also been looking at other things as well. So I've sort of stepped back a couple of generations from what's the bleeding edge at the moment with transformer models like OpenAI is using, and looked at something called a CNN, which is a type of neural network. I'm probably not going to demo this to you because I'm running out of time a little bit. But basically, this was built from scratch in JavaScript. So it was completely built in JavaScript using TensorFlow.js. The model was generated in JavaScript. It runs really quickly at about 26 milliseconds. It's got between a 94 and 98% accuracy, and it tells the difference between whether a job advert is written by an agency or has been written by a direct employer. something that I need for the scraping work that I've been doing. I need to be able to tell those two things. And it's slightly older, but it works really well. And the thing about a CNN is it's much smaller as well. The model's only a few megabytes. I've actually deployed this through Node onto an £8 a month server, and it works perfectly. So it's quite interesting to be able to move back a little bit and go into some of the technology that's prior to that, and it's still really useful for very specific use cases. But I want to learn more about how you can use transformers, because that's the sort of state of the art at the moment. And in the Python world, they have Hugging Face, which is this amazing site. It has literally thousands of models on there for you to play with. I think at the moment, if we're looking at the number or something, it's like 160,000 that's uploaded on there. And it has all of the current best language models from places like Facebook and Google. And you can use them and then put your own training on top of them. But they seem to have been, until recently, out of the reach of someone like myself who's doing stuff in JavaScript. That was until this happened. This happened in the middle of summer last year. There's a group called Onyx, which is the Open Neural Network Exchange, who are doing this project, which is basically the ability to take models that are generated in things like PyTorch or TensorFlow and use them or reuse them. So a simplest way to understand this, and it is a very simplest way, is they're trying to sort of Dockerify the whole sort of system a little bit. They can take these models and then deploy them onto different systems and execute them. The great thing is that they wrote this WebAssembly, which means that we can execute them in JavaScript, which means you can execute them in a browser and in Node. And we can use that in the types of code and the work that I'm doing. And there's another thing that's happened, which is the quantization of things. That is basically squashing down your models so that they can be used in environments like the ones that I want to use. You lose some of the precision in it. So it's a bit like, I suppose, from our perspective, if you're thinking of a front-end coder, it's a bit like using something like JPEG. You still get a great picture. Some of the results I've seen is like to take a model that predicts at 90% and brings it down to about 80%, but you see like a quarter of the size the model is. So that helps a great deal. This combination allows us to create things where we can actually execute complex, large models in the browser. So hopefully I can show you some of that in operation. So let's start with a quick one. This one's actually running in the browser. The whole model, everything's running in the browser. So, see if I can get the spell right. And what it's doing is it's looking at how I'm writing and the things that I'm writing about and detecting the emotions in it. So if I put in I liked it, saying love. If I switch that to hate, annoyance, anger, disgust. And this is a model, a transformer model working within a browser. It can do other things as well. Hopefully we can see one here. This model is one that's a bit like some of the code generation you've seen. I probably just need to collapse that down a bit so you can see it. So I've started the beginning of unfortunately this model is only working with Python, i.e. only can write Python, but I've given it the beginning of a Python function, and if it's working, it will complete and finish the Python function for me, all in the browser, working and operating in the browser. Let's get back to my slides, just to finish. I think, from my perspective, that we're starting to see the beginnings of a point of democratization and commodification of this area of computing. It's becoming easier for people like myself to start playing with it and understanding it. The cliff edge, or the cliff that used to be how you join this and get involved in it, which was all about learning mathematics, is getting a lot less. That doesn't mean that you don't need to know that, and I definitely need to know it. I've got so much more to learn. I reckon I've got at least another 2 years of looking at this before I really know what I'm talking about. But I've been able to build within a few months models myself, using data myself, that are of a commercial quality that I can productize and use in things that I can use myself, which means that I'm on the road. And as soon as you can get advantage out of something and do that, you work your way into a subject. Before it was a lot more difficult to do that. So it's a really fascinating time. I'm really enjoying this journey, and that's the reason why I wanted to share it with you. And I hope that some of you will become interested in it as well. So thank you.
Cool, thank you, Ryan. That was great, really interesting. I think even just in the past few weeks, in the news, we've seen so much about this topic, and there's so many tools that have been released even in the last couple of days. And I think that, as developers, it's quite exciting to have the opportunity to work and understand these tools, to kind of squeeze value out of them. I think it's probably going to be necessary for some of our jobs in the future to kind of really understand those. So thank you for that. Does anybody have any questions for Glenn? First one from Tom.
Thanks, yeah. It's very interesting. How do you know what size is big enough for training a model or fine-tuning a model?
So, I mean, basically, you could, I don't know if you saw the figures there. I was using very small numbers. So 1600 was what I was using for the job titles, and I was getting up to 90-odd%. I think I could probably still go quite a lot further than that. And I was in a very small domain as well. So it's all about the UX job titles. I suspect, depending on how you broaden that, whether it would still work, would be a really interesting call to go. Experimentation. Everything with this is experimentation. Try it, see it, rip back again, test it, and you keep going until you can't get any more gain, I think is the answer to your question.
I think it's really interesting that you sort of go into ML from like a JavaScript point of view, and like having gone on that journey, I just wonder, like considering how many tools exist in like the kind of Python world compared to the JS world, do you think that the time that you spent learning the fewer tools was better or worse than the extra time that you'd have spent dealing with Python?
Yeah, it's a you know.
Because I'm a developer. Obviously I'm a JS developer as I'm here, but like I'm just curious because like you've done it one way, and is it good?
So yes. So apart from being a complete pedant, I think there is an advantage to it. I found sometimes that when I learn in coding, you often just copy and paste without actually learning the fundamentals a great deal. And I have been doing stuff in Python, and actually I found that I'm quite attracted to it as a language, a lot more than I thought I would be. But what I've learned by translating it is I've had to learn the fundamentals. And sometimes there's gaps. So some of the things like being able to tokenize words, so basically the bit where you break the words up, there's a lot of the transformer models break into subverbs. They don't use like the full word, they break them down. There's advantages to doing that, which means that the encoders are really much more complicated. Some of them are not available. Some of them you have to actually go out and actually code yourself. And in doing so, I've learned a lot more. So yes, it's been a very expensive way of doing it, and maybe something I might not redo again, but it has helped me learn.
Awesome. Yes, we've all been in those projects where you sort of accidentally 3 or 4 days later, working this. More questions for Rory?
Cheers. I'm really excited by the in the browser models that you deploy, and do you think are the main advantages just like inference speed and having it on the model? Do you think there's a future in which the models are sort of deployed locally on your device and you no longer need this outgoing internet connection? How lossy did you find the in-browser versions of them in comparison to hitting OpenAI's API itself? Yeah.
So basically, they usually start with the smaller models. So for example, BERT, which is a commonly used model, there's about 60 variants of it, and there's Distill BERT, which is a very smaller version, and then they even crunch that down. So there is a degree of loss in there. It's a playoff. And it depends what you're trying to do, because sometimes you can find that you can use some of the smaller, more precise models that are aimed at specific use tasks that are not that big to start with. And if you're doing that, then you can actually use them. Some of them that are loaded into here are between sort of 4 and 40 megabytes. That's a lot to stick into a browser and pretty unpractical from outside of the demo at a meetup. The beauty about it, though, is what we're starting to see as it's democratized and people are looking at these big language models, which are huge, they're many gigabytes, people want to run it on their local machines. So on this machine, I've got something called Alpaca, which has just come out, which is one of the Google's BART system, which they released for educational review, actually running locally on this machine. It's not very good. It's one of the smaller models, but it's pushing people to try and make this stuff so that it can run locally or on other devices or be distributed across maybe 2 or 3 devices in your house and use it. So these are the answer to your question, they're not really practical, but what you're seeing is the first stages of people grasping this technology and trying to bring it in and use it themselves and democratize it.
Cool. I'm going to pause the questions there, because we're sort of running out of time. So thank you very much, Glenn. Glenn said you'd be on the Discord. If anybody's got any further questions, so you can find the Discord at scottishtechnology.club. Yeah, post away there, and also just post stuff about JavaScript or any other things that you're interested in. Try to create a little bit of community around that. So yeah, thank you, Glenn. Just a couple of other housekeeping things for EdinburghJS. Next month, it is the 20th of April. That's a Thursday night. We'll be back here, kind of usual time, usual place. We've got Tom speaking, and we've got Orkan showing some stuff on a side project. We still need additional speakers for May and June, so if you're interested in speaking, I know some of you have filled out the questionnaire that we had earlier, saying you'd be willing to speak, so I'll be in touch about that. If you want to give a technical talk, if you want to give a kind of share your stack that you use at work, just for a kind of intro to who you are and maybe a startup that you're doing or side project, that's cool as well. I'd like to thank KPV Lab for the food tonight, both of our speakers. I'd like to thank Alan and Jack at Product Forge for live streaming to YouTube, and Natalia for helping out welcoming people and registering them. So I won't be here next time. I think it'll be Conrad hosting. So I will see you in a couple of months' time and enjoy the next meetup. See you soon, guys.